I just realized that we were in the previous two synthesis videos that were just making stuff that had two substituents on, so I thought I would add something that has three substituents for you to practice. Also, there's within the chapter, again with answers at the end of the book, number 22 and 23 are synthesis practice problems as well. So if you want, go ahead and pause the video and figure out this problem. What are you going to add first, second, third? How do you put this together? Okay, so what you're seeing right away is that we have three groups and they are all in meta relationships to each other. And so if you're going to do some sort of efficient synthesis, then you had better be adding meta directors first. So here is an orthopara director. That's not directing anything meta, and so that would be, you wouldn't be adding that first. Here we have a meta director, and here we have a meta director. So what does that tell you? Well, it tells you right away you're going to add this last. Now we have a meta director here, so if we added that first, that would direct this one meta to it. If we added this first, then it would direct the nitro group meta to it. So does it matter? Does it matter at all whether we had the nitro group first or the ketone group? Did you remember the problem? This is Friedel-Crafts reaction, Friedel-Crafts acylation. If you tried to add this group on a strongly deactivated ring, nothing would happen. So you have to add this group first. That directs this next group into the meta position. So you're going to add that group second, and then you're going to add this one last. If you do not do it in that order, then one thing or the other will go wrong. Either the reaction won't happen at all, or you'll be directing things in the wrong positions. So let's go ahead and draw that out then. Beginning with benzene, we said we had to add the ketone first. Kind of a funny looking thing. Did that scare you when you saw that? Thought I'd never seen anything like that in my entire life. Well, it doesn't matter what this is, whether it's a methyl group or a cyclopenyl group, it's the same exact reaction. It's a Friedel-Crafts acylation. So add that first, and that is directing into this meta position and this meta position, and doesn't matter which one it adds to, it's the same exact product. So we are adding nitric acid and sulfuric acid. One, two, three, four, five. Get lost trying to make my rings. Sorry, this bond is way longer than that one. It got distorted a little bit there. Here is your nitro group. And now the nitro group is directing in this position, strong deactivator. The ketone is also a strong deactivator, directing in the same position. Roughly the same amount of deactivating going on, and fortunately they're reinforcing each other. and then to get the final product, then we just add our bromine to that. And it's not going to add very fast. That's the other thing to keep in mind when you have strong deactivator on the ring. That makes the reaction a lot slower. When you have two strong deactivators on the ring, then it makes it even slower. And so that would be a major problem if we were trying to add something by Friedel-Crafts, because the Friedel-Crafts reaction just is not very fast, and it will not happen at all if it's got even one of these deactivating groups on. But these are kind of fun. I mean, you can think through, you can figure out what kind of directing needs to happen, you can figure out the limitations on the various reactions, and find out the very best way to do one of these syntheses. So you're going to have OWL syntheses to work on. You can do these practice ones there, and I think I'll come up with another sheet of practice syntheses. Of course, the old exams have examples of those as well. And so at this point, then, you just want to be practicing your skills and so you're pretty good at solving a puzzle that has an aromatic ring and a bunch of stuff that you need to add to it.